In this application, we're going to be looking at the white light confocal, and here you can see the probe, and there's the white light spot right there. And this is the CL2 MG210 probe. So this is one of our more accurate probes. And this was, so it's a little difficult to get an actual thickness on this thinner material. So what we did is we put it across a tooling bar and we applied a little force to it so that when we scan across it, we can get that step height, which will tell us that that is the thickness or the height of that material. So let's go ahead and we will go ahead and walk through them. Here's the first scan. And here you can see what we did is we scanned 10 millimeters by roughly 2 millimeters across that target. We took a data point every 5 microns along the X, and then we would jog it down 100 microns and take another scan. So that's why it looks a little stepped, because we only took a scan every 100 microns. So let's go ahead and take a quick look at this where we've optimized the color. And this is a 3D view of that. And let's just put a color scale on there so you can see. So you can tell that we're getting really good data. There's that step height. And if we come back to this, let's take a profile across it, pretty much at the dead top center. And of course now we can see what that height is by doing some sort of basic measurements. And as you can see, we have a little waviness in it. Not sure if that's from the fixture or the material. And so here we're saying there's a height difference of 58.131 microns from that step height. So let's look. This was that was a blue non-LM 2 mil target. That was 21, and let's take a look at 22. And I'm just going to walk through these pretty quick, so you should be able to get a good idea of how these are performing. And once again, let's take a look at the same setups. And as you can see when I'm bringing through this, it gives you a really good feel for the resolution and the accuracy of the CL2 probes. And let's take a measurement of this also. And so you can see at this side we're about 55, and here we're at about 58 microns. So that gives you a good idea. It is possible with these tools that we could come in here and level it a little bit more using some software. So and once again, that will give us a better feel for that step height or the thickness of it. Now I'm showing 54.489, and as I move it across to this side, I'm at 49 or 50.17. So still a couple microns. And from this side to this side, it's 60. It's also possible that we can zoom this up so you can get a better idea of what this surface is looking like. And this scale is from roughly -2 to 1.5 microns, or that's tenths of thousandths. And of course, we can also take a look at the surface roughness, right? Here's the R sub A value of 0.222 microns. Also possible to do a surface area on the complete product, and these are to ISO standards 25178, and that's called an S of A. right, which is 288. So a lot. The product is definitely not as smooth across the range. So let's take a look at another. Let's take a look at the clear natural. And let me just clean up some of these templates. And here at 48 is the surface area, so much smoother it appears to be than that first target. And once again, let's just come across, and you can see most of these are going to look pretty similar. And so what this is really showing us is that with the white light confocal, we're not going to have any problem with color or material or transparency. And so we're showing about 52 microns. And you can see we have pretty level. We're down to 355 nanometers from the tooling rod to the tooling rod. And so here I'm showing it as I scroll across here, about 52 microns. So that was the clears. Let's take a look at one of the white. And as you can see, we have done a lot of scans on these materials, and we'd be happy to do more. But just for the sake of sort of going through them a little quicker, I think you'll see that we're getting a good feel for being able to measure any of these targets without any problems. S of A, for about 46 microns for the S of A. Once again, let's zoom that up. And let's look at the profile across there. And as you can see, as we move it, on the further edges, we're not flat against that tooling bar, and so it tends to shift a little bit. And once again, if we come in here, 57 microns, and you can see this surface is quite a bit rougher. It's doing 3, 4, 5 microns, and up to here 62. And let's just zoom this up real quick and take a look at that. So here you can see peak to peak, we definitely have over plus or minus 2 microns. And let's do the last one, a yellow. I see that we have an LM, and I'm not quite sure what the nomenclature is, but as you can see, we're not having any problems with the surface or the textures. Our S of A is about 47. And so there's that surface. And once again, we have it in 3D. And you can sort of get a better feel for, we're seeing all those edges really well on this surface. And you can see the sort of striations across here that we're able to pick up. So let's go back and do a profile across the top dead center. And once again, from a low, it appears right here, there's a little low spot of about 44. And we're in that 48, 45. And you can see it's a little, definitely got some features on it. It's a little smoother here. And once again, if you look at the rod, we're within 123 nanometers of being level. So definitely doing the job on the target and on the surface of this material.